Okay, so we're going to start looking at expressions and equations. And when I say expressions and equations, we're going to learn how to work with them and not just what they are. So the title of these notes is Expressions and Equations. Okay? So an expression, just to review, an expression is a collection of variables and coefficients and operations, but there's no equal sign. So this would be variables, coefficients, and operations. And an equation would be expressions and an equal sign. The equal sign makes it an equation. So, okay. So, let's look at an example of an expression. X plus 3. Okay, so just to review some terminology that we've already learned here. Of course, the x is a term and the 3 is a term, and they're separated by this addition. So this is two terms. So x is a term, 3 is a term. So this has two terms. This expression has two terms. Okay? So the x is an unknown. It could be anything. If we choose x is 10, then 10 plus 3 is 13. But if x is 7, then 7 plus 3 is 10. This has no set value. We can't say this equals something, because that would turn it into an equation. It is not an equation. So don't think that you're trying to figure out what x is. I want you to forget about that idea right now, because that's really not how we approach algebra. X plus 3 is a figure of speech, really. It just means some unknown value and then 3 higher than that. Okay? So suppose you have x plus 3, and if I tell you that x equals 4, then you simply plug in the 4 where x is, and voila, you have 4 plus 3. Clearly that is equal to 7. But a more complicated example might be 2x minus y plus 6. Okay, so how many terms is in here? Let's do this one in green this time. So 2x is a term, minus y is a term, and notice that I'm lumping in the minus with the y because it's part of it. Okay, so minus y is a term, and then 6 is a term. And so this has 3 terms. Okay? That has 3 terms. So what if I say, okay, well, x equals 4 and y equals 1. Well, this is a little bit more complicated than our previous one. In the previous one we just said, okay, well, if x equals 4, then x plus 3 is the same as 4 plus 3, and that's equal to 7. Okay, we said that. That was pretty easy. So now let's say if x equals 4 and y equals 1. Okay, then 2x minus y plus 6 is the same as 2 times 4 minus 1 plus 6. And again, I'm using this, and I want you to get more comfortable with this parentheses to mean multiplication. This means 2 times 4, okay? And I got that because the x was 4, so all I did was I just came in right here, and I said, okay, well, if x equals 4, then I'm just plugging in a 4 where the x was. And notice that I'm not turning this into the number 24 because this is 2 times x, so this is going to be 2 times 4. And then the same thing could be said for the y. If y equals 1, well then y equals 1, and I'm going to come in and put a 1 right there. Okay? And it's minus y, so it's minus 1. Okay? And so then we could use order of operations to know that we need to do the 2 times 4 to get 8, minus 1 plus 6, which is, of course, 8 minus 1 is 7, plus 6 is 13. And so there you have it. Okay? Now, we're going to spend, this year is pretty much going to be half and half dealing with expressions and equations. We're going to learn techniques to do both. And so this is an expression technique, and now we're going to learn an equation technique. And they're both equally important. Okay? Okay. So now, for equations, I want to talk about how do you solve equations. And when I say solve, this is a new word we haven't seen before. How do you solve equations? I'll put a little question mark over there. When we solve an equation, it means, solving an equation means finding what the variable is, what value it is, okay? Or it may be more than one variable. Maybe you're solving for 2. You know, we can do all kinds of things like that. But solving means that you're really finding out what it is. And you may think you just have to do it in your head and maybe a guess and check, or just think about it until you figure it out, and that is not true at all. The reason that we study algebra as a part of mathematics is that there's actually a way of doing all of these things that you follow a method, and it's a very systematic way to start, and you go through the steps, and then you end up with an answer that's correct. Because something basic like, here's an example, something basic like 3 plus x equals 8. Well, this is pretty easy, and we can all look at this and go, oh, well, I think x has to be 5, because if x is 5, then I have 3 plus 5 equals 8. And so that makes sense. But this is a very easy, actually I don't even know of an easier equation than this. So this is an absolute best case scenario that's the easiest thing that's out there. And so we can look at this and think, oh yeah, well, x has to be 5, but this is the most easy scenario that's possible. And the reason that we're going to learn the techniques and learn the actual mathematics and the algebra behind doing this is because these are going to get much harder throughout this class and through classes that you have after this. And so we learn systems that will work for everything, and then we can apply them to a simple equation or a complicated equation, whichever one we want to. Okay? So yes, it does make sense that x would be 5 because 3 plus 5 equals 8. But let's think about how we can actually do this using algebra. Okay? So there are steps. Actually, there are 3 steps that I want you to commit to memory here. Okay? The first step is isolate the variable using inverse operations. Remember, inverse kind of means backwards, right? Number 2, we work backwards. And so if the order of operations, and I'm talking about order of operations here, if the order of operations is PEMDAS, and I'm telling you, okay, now you need to go backwards, then we need to go like this, okay? And so it's SADMEP. And parentheses don't really count, so we just left with SADME. Okay, SADME. So we're really working this way. And then third is whatever you do to one side, do to the other. Okay? Whatever you do to one side, do to the other. So if you do some operation, you have to do it to both sides. And when I say side, I mean sides of the equal sign. Okay? So let's think about this question again using these 3 steps. Okay? Isolating the variable using inverse operations. Well, that means we're going to be looking at the variable, and the variable here is the x. And so this is really what we are the most interested in, because that's what we're trying to solve for. And so we have 3 plus x equals 8. And so we ask ourselves, what is happening to x? And this is really the question that you're going to be asking yourself a lot. What is happening to x? So, answer the question. What's happening to x? Well, it's being added by 3, right? X plus 3. Because I could rewrite this. I could rewrite this as x plus 3. 3 plus x and x plus 3 is the same thing because of the commutative property, if you remember. So I could rewrite this and say, well, what's happening to x? Well, I'm adding 3 to it. So then, what is the inverse? What's the opposite of adding 3? Well, it's subtracting 3, of course. So let me just highlight over this with a little of that. Okay. So, of course, it's going to be subtracting 3. And so if x is being added by 3, and we want to do the opposite of that, then we're going to subtract 3. But whatever you do to one side, you have to do to the other. So I'm also going to subtract 3 over here on the other side of the equal sign. And so if you want to think about it this way, you can think about, this side of the equal sign, and then equals, and then this side of the equal sign. Okay? And so whatever you do to one side, you have to do to the other. I'm subtracting 3, which I'm doing right here. I'm subtracting 3. So I also have to do it over here. And that's because in order to maintain an equal situation, it's like a seesaw. Whatever you do to one side, you have to do to the others. Otherwise, it would get out of balance. So then we're going to rewrite this, and you're not going to have to do this once you get good at this, but for now I'm just going to make it very clear as to what I'm doing. So if I shove this in, if I shove it in right there, you kind of see what I'm doing, I'm just kind of shoving that in, and I'm kind of shoving that in right there. Okay, then what I have is the 3 plus x minus 3 equals 8 minus 3. And so here is the minus 3, and here is the minus 3 that I just put in, minus 3 and minus 3, right? And then here was the x. Here's the blue x right here. Okay? Okay. And so now I'm just going to think about, well, what is 3 plus x minus 3? You can also rearrange this using the commutative property. I could commute, let's say I can commute these two, okay, and I could say, well, x plus 3 minus 3 equals 8 minus 3. But what's plus 3 minus 3? It was just 0. So this whole side right here just becomes x plus 0, and 8 minus 3 is 5. And x plus 0, as we already know, is just x. We don't even have to write the plus 0. And so lo and behold, here we are, and we are left with our x equals 5. So we're going to do a more complicated example of solving an equation and I use EQN for equation, solving an equation with more than one step. Okay? More than one step. If you looked at the last example, we just had one step. We just had to subtract 3, and then we were at our answer. So what happens if we have to do more than one step? Well, let's look at something really crazy. Here's an example. What if we say that 5 equals a divided by 4 plus 2? Okay? So again, of course, looking back at our original vocabulary lesson, you know, this is a term right here, right? This is a term. This is a term. This is a term, right? And this is a term because a divided by 4, it would be the same thing as saying 1/4 times a, which is, of course, multiplication, which is what glues a term together. So, and then the plus right here is separating those two terms. Okay? So what would we do in a situation like this? Well, we still ask ourselves, and I want you to get into a habit of making yourself a little chart over to the side of your paper. So you ask yourself, okay, well, what is happening to A? Okay, well, what's happened to A first? Well, it's being divided by 4. And then after all of that happens, then what's happening to it? Added by 2. And of course, I'm separating this. The equal sign is helping me separate the left-hand side from the right-hand side, right? And so we're only looking at what's on one side of the equal sign here. And then this is on the other side. And so those two sides are equal to each other. So the A is being divided by 4, and then it's being added by 2. Okay? So if that's the case, then what are we going to do? Well, we're going to do the exact same steps backwards in reverse. So if the last thing was adding by 2, then we're going to do adding by 2, but we're going to do the inverse of it. So we're going to subtract 2. And then if I'm working my way up here, so here we're going, we're essentially, I'm working this thing backwards, right? As I'm going down like that. That makes sense? So I'm adding by 2, which means I'm subtracting 2. And now I'm going to divide by 4, which means I'm going to multiply by 4. Because in our 3 steps we talked about using the opposite operation. So this is literally what you're going to do to solve this right here. You just made yourself a little check sheet. And you do it in this order. Okay, so I'm going to rewrite our equation right here. So 5 equals a over 4 plus 2. So the first thing we need to do is subtract 2. And where are we going to do it? We're going to do it to both sides. So we're going to subtract 2 and we're going to subtract 2. Okay? And I can even write this in red so that it really stands out. I'm subtracting 2, subtracting 2. And again, I have a little imaginary line right here that's dividing the two sides of my equation. Okay? So I'm subtracting 2. And so 5 minus 2 just leaves me with 3. The a minus 4 plus 2 minus 2, well, those are going to cancel each other out. Plus 2 minus 2 is 0. So I really have a over 4 plus 0, but I don't have to write plus 0 because that doesn't tell me anything. Okay? And so now I have done this step. I have subtracted by 2, and now I just have to multiply by 4. And again, I'm going to do this to both sides. So I'm going to multiply by 4, and I'm going to multiply by 4 over 1 here because I want to write it as a fraction. And I'm going to multiply by 4 over here. And I'm writing the one on the right as a fraction because I already have my variable involved in a fraction. And so this is going to make it really easy for me to deal with this. Now on the left I have a 12 because 4 times 3 is 12. And on the right, if you follow the rule for multiplying fractions, you have a times 4, which of course is 4a. And then on the bottom you have 4 times 1, which is 4. You can do all of that, or you can remember how to cancel across fractions when you're multiplying fractions. Simplifying fractions is another way of thinking about it. And the 4 cancels with the 4 because of the commutative property. 4 goes into itself once and it goes into itself once. So really I just have a times 1 over 1 times 1. Well, all of that is just a. And so 12 equals a. And indeed, if you look back at what we have just said here, what we have said is that going way back up to the top, 5 equals a over 4 plus 2, but we have just determined that a is 12. And so we indeed have a correct statement. 12 over 4 is 3 plus 2, and sure enough, 5 equals 5. And that tells us that the a that we found, that tells us that that is correct.